Alright, so in this video we're going to be looking at vector pathways. So the key thing to keep in mind is that a vector represents a journey from point A to point B. However, the vector only cares about the end point in relation to the starting point. The route it takes does not matter. So when it comes to vector pathways, you can take any route you want as long as you can get from point A to point B. So what I mean by this, here I've got a little doodle of a mouse and a cheese. I had a lot of fun doodling them. So my vector from the mouse to the cheese, I could say that it's just vector C. So that's my straightforward, obvious vector to take, obvious path. But the mouse could go down first, along, then up, then across, and then let's just do a little wiggle here, and then to that cheese. However, it's still going to come to the same point, and that would still be my vector C. My mouse could also completely go past the cheese, then back, then past again, and then come back here, and that would still be my vector C. So it does not matter what journey the little mouse takes. As soon as he gets to that end point, that vector is the same no matter which route it took. So let's take a look at some examples and some questions on that then. So here I've got the diagram below represents rectangle ABCD with M as the midpoint of DC. Vector A to B is U and B to C is V. In terms of U and V, find the following vectors. So to start off with, I want to find the vector A to D. So one of the things to keep in mind is that parallel lines with the same length have the same vector. So this A to D, that is going to be the same as this B to C here. So A to D, I can make a note here that that is also going to be my vector V. So A to D is the exact same as B to C, which is just going to be V. And now I want to find out my vector pathway from A to C. So the route that I could take from A to C, so what we kind of think about it is this direction here, but obviously I don't know what that diagonal is going to be, so I've got to look, right, what other paths could I take? So I could go from A to B and then B to C, and in fact along that way I know what all the vectors are, so that's exactly the route I'm going to take. So I'm going to go from A to B and then B to C. So A to B is that U, and then B to C is that V. This time I want to go from C to B. Now the thing to keep in mind, I know that B to C is this vector V, but if I'm doing from C to B, I'm going against the arrow that was here. And when you go against the arrow, then it's going to be the negative version of it. So it's essentially, I'm doing the negative version of B to C. So that means I'm doing negative V. All right, so this time I want to look at my route from B to D. So the route, one of the routes I could take is from B to A and then A to D. So I want to go from B to A and then I'm going to go from A to D. Well, B to A goes against the arrows, so that's going to be a minus U. And then A to D, I'm going with the arrow, so it's just going to be that plus V. This time, I'm going from D to M. I know this entire journey along the bottom here is going to be the same as this up here. So it's going to be that vector U, that entire path. So this vector, so that entire journey there is going to be vector U. But I know that M is the midpoint. So I'm only going halfway that distance of D to C. And D to C is just vector U, so that's going to be half of U. And then my last one from M to B. So M to B is going to be from M to C and then C to B. So I'm going from M to C and then C to B. Well, M to C, that is still halfway along that line. It's still going to be that half U. And then C to B, I'm going against the arrow, so it's going to be minus V. All right, so let's take a look at another example then. So next one here, I've got the diagram below represents a trapezium with side DC twice the size of AB in length. Vector AB is U and BC is V. In terms of U and V, find the following vectors. So to start off with, I want to find this total length of this total vector of D to C. Now this is the key bit of information that I've been told here. And that is side DC is twice the size of AB in length. Now, because it's a trapezium, that means these two lines are parallel, but they don't have to be the same length. However, think about it this way. I know that D to C is twice the amount of AB, so I can apply that to my vector as well. So I know the vector DC is twice the vector A to B. So that means it's just going to be 2u there. So vector D to C, that's going to be 2u. Okay, now I want to find A to D. So here I've got a bit of a journey to take. I can't do this little shortcut here because I've got no information there. So I need to take the long route. So I'm going to go from A to B, then B to C, then C all the way across to D. So I'm going to go A to B, B to C, and then C to D. So A to B, I'm going along with the U, so that's plus U. Then I'm going along with that arrow with the V. But then here I'm going against the arrow, so it's going to be a minus 2U. But I can collect my like terms together when it comes to vectors. And here I've got U take away 2U, so that's going to be a minus U there, then plus V. You must collect your like terms together with your vectors to make it as simple as possible. Then lastly, I want to find my journey from D to M. So my options are to go from D to C and then this C to M here. So I'm going to go from D to C and then C to M. So D to C, I'm going along with the arrow, so that's going to be 2U. Then C to M, again, I know M is the midpoint, so it's halfway along this line here. So it's going to be halfway of this vector. So it's going to be a minus, because I'm going against the arrow, then half of that vector V. All right, so let's take a look at the next one. So this is our last one to look at. So here we're told the diagram shows a tiling of congruent triangles. Now the thing to keep in mind whenever you see this word here, congruent, that means they are the exact same triangle, just they've maybe been rotated about. So vectors U and V are represented by A to B and A to F respectively. So the first thing I'm actually going to do here, before I even look at the next part of the question, is because I know that every single one of the triangles here is going to be the same as this triangle, I'm actually going to start matching up the parallel lines, the lines that are the exact same with the vectors, because it's just going to make A and B really, really easy for me. So A to B, that's going to be the exact same as this B to C here, so that's also going to be U. And they're going to be parallel with this F to E and this E to D. And then parallel lines to that V, so make sure you pay attention, it's going in this sort of direction, so it's going to be this B to E and this C to D as well. So that's going to be V, and this also here is going to be V. So the first thing I want to find express A to D in terms of U and V. So thinking about my route from A to D, I can go from A to B, then B to C, then C to D. So I'm doing A to B, then B to C, and then C to D. So A to B is U, B to C is U, and C to D is V. And then collecting my like terms together, I've got two lots of the U's there, So that's going to be 2u plus v. And then part B, we're being asked to express c to e in terms of u and v. So c to e, I don't know what this line here is, so I need to look about alternative routes. And I could go from c to d and then d to e, and that will get me there. So for my vector journey of c to e, I'm going to go from c to d and then from d to e. So c to d, that is going to be that vector v even. And then d to e, I'm going against the arrow, so it's going to be a minus u. So that's my vector pathways there. And it is just about taking a look at what lines are the same, what lines are parallel, and what potential routes could I take to get to that end goal, no matter how long it takes. Let me know if you have any questions, and good luck with the work.